To begin, what is the coefficient of determination? What does the concept do? To elaborate more on this idea, it allows one to calculate the predictability of variance within the data. Variance can be understood as the quantifying of the data or the measurability of how separated the values are on the graph from their average value. Another way to interpret this is by understanding that by calculating r squared, we get insight in the direction and strength of the data set and its values. The idea is calculated by the y values, which helps predict the x values. Once calculated, the r squared will demonstrate if the graph has values of correlation or not. I have incorporated a few examples to signify a few correlations, a positive, a negative, and also one with no correlation at all, with the hope that by visually seeing it, it will help you understand the concept better. Now, in the following slide, to further explain, a graph with an ideal and perfect correlation has a value of 1. A bad graph would be one with 0 correlation. For example, if we were to calculate the coefficient of determination for a data set, and we derive a correlation of 0.83, then we can conclude that it is a good correlation. That is because the value is close to 1. A correlation of 0 would mean that there is no relationship with the values, and in other words, it would mean that the data is randomized. The coefficient of determination is involved substantially in the basis of engineering. It helps comprehend large amounts of data and helps one visually see the changes, either increasing or decreasing, of whatever is being measured. It helps understand the relationship and direction of the information that is being tested and where it is headed in regards to results. Included on this slide is a diagram that I have provided to help interpret a modern-day example. We could say that the CDC is testing for a cure for COVID-19. The independent variable X would be the cures for COVID, and the dependent variable Y would be the population of people infected, or in other words, the cases present. If the cure seems to be helping people, we would see a negative correlation because the cases of individuals would be decreasing while the cure amount would be increasing. Also vice versa. If the cure doesn't seem to be working, we would be left with a positive correlation showing an increasing amount of cases. In engineering, this concept is used to calculate the changes of products, designs, and other tasks, and the effect it has on other variables that are being studied. According to the article that I have included, which is referred to as the coefficient of determination, what determines a useful r-squared statistic? Engineers were investigating a risk calculator that would depict the progression of glaucoma in patients. They used two models. One was the New York Glaucoma Progression Study to get their information on patient progression as well as the rate of this progression. The data that they collected was added to their model, which was used to validate their findings. They also verified their data with a diagnostic advanced imaging in glaucoma study. Their research was a great attempt to quantify the progression in glaucoma, but proved to be not as precise. Some limitations to this concept were presented in another article called The Coefficient of Determination, Some Limitations. I found out that if the r-squared is too big in regard to a large data sets, then the precision of the model begins to deteriorate. When analyzing regular values in a graph for a statistical problem, r-squared works perfectly. But when we increase the data and it becomes considerably large, it hinders its abilities. Nonetheless, the concept is very beneficial for the interpretation of information and its relationship for the variables that brought its data to